Dear students, today we will discuss about reflection, refraction, and total internal reflection in case of light. These phenomena are very important for a diploma engineer student. First, we will take what is reflection of light. When a ray of light traveling in a medium strikes a polished surface like mirror, it comes back to the same medium. This is called reflection of light. So, when a ray of light traveling in a medium strikes a polished surface like mirror, it comes back to the same medium. This phenomena is called reflection of light. Suppose we have a mirror a ray of light strikes perpendicular to the mirror, it will come back along the same path when it strikes at 90 degree to the reflecting surface, that is the mirror. On the other hand, if it strikes obliquely, that is at certain angle, it will reflect like this. This is the mirror. This ray is called incident ray. This is the point where the ray of light strikes the mirror surface, and the perpendicular at the point of incidence is called normal. And this ray is called reflected ray. So, we have two rays AO and OB. AO is called incident ray, ON is called normal, and OB is called reflected ray. This angle I which the incident ray makes with normal, this angle I is called angle of incidence. I, the angle which the incident ray makes with normal, and the angle which the reflected ray makes with normal, that is called R. R means angle of reflection. In our first case, I, angle of incidence, this is the normal, so I is equal to 0 degree, R is also 0 degree, because the ray of light is incident normal to the mirror surface, and we are considering I and R, which are the angles made with the normal. This is very important to understand what is meant by I and R. Now, this reflection follows certain laws which are called laws of reflection. First law is the incident ray normal at the point of incidence and reflected ray all lie in the same plane. This is the board on which I am writing. This is the one plane, and you must note all these incident ray, reflected ray and normal, they are on the same board, that is they are in the same plane. And the second law is the angle of incidence is always equal to the angle of reflection. These are the two laws which the phenomena of reflection of light follows. I is equal to R. Angle I is equal to angle R. Angle of incidence is always equal to angle of reflection. Now, in case of light, we have a relation C is equal to nu lambda. C is the velocity of light, nu is the frequency, and lambda is the wavelength. When light strikes a reflecting surface, it comes back in the same medium. So, in reflection, neither velocity nor frequency and also wavelength, they remain same. They don't change when reflection of light takes place. This is very important to note कि which parameter changes when a reflection of light takes place. None of these, neither velocity, frequency, wavelength changes when reflection of light takes place. Reflection is of two types. One is called regular reflection, another is called diffuse reflection. If we have a perfectly reflecting surface and a parallel beam of light falls on the surface, it will be reflected in the same direction. All these like 1 and 2 rays, they are following the same direction. This is called regular reflection. On the other hand, if the surface is not perfectly smooth, then a parallel beam of light striking such a surface will not go parallel after reflection. This type of reflection is called diffused or diffused reflection. So, reflection is of two types. Now, we will discuss about plane mirror. First of all, how the image is formed in case of plane mirror. This is the plane mirror. We have a object here, then how the image of this object is formed. Suppose a ray of light strikes the mirror, then it will come back. Another ray of light strikes the mirror at this point. If this is the normal, it will go making the angle same along this direction. Now, one ray is coming towards left along this side, another is coming along this side, they will never meet. But if we produce them towards right, they will meet at certain point, which is called I. This is the mirror and I is the image. Of this object O. How the image is formed in case of plane mirror? So, we take at least two rays. One is the which is striking perpendicular to the mirror, another is obliquely at certain angle I. Then these two rays after reflection, they are not meeting at any point, but they appear to meet at the point this image I. So, what are the properties of the image I? This image is first of all virtual, because rays after reflection from the mirror do not actually meet, they appear to meet at point I, hence the image is virtual. Image is erect. Image is of same size. image is at the same distance from the mirror as the object. As the object is in front of the mirror, the image will be as far as behind the mirror. And the last point is, it is laterally inverted. These are the 5 characteristics of the image formed by a plane mirror. Laterally inverted means, if we have a mirror, we have object of this type, then its image in the mirror will be like this. So, the image is laterally inverted, there is lateral inversion in case of this plane mirror. Now, number of images. If we have 2 mirrors which are inclined to each other at certain angle theta, and we have an object placed in between the mirrors, then the number of images will be 360 degree over theta minus 1. This is a very important formula for calculating the number of images formed by the mirrors which are inclined to each other. So, we can make a table for different angles. Suppose the angle is 30 degree, images will be 11. You can calculate by using this formula. If we have angle 45 degree, then this will be 9. If we have 60 degree, this angle will be 6 minus 1, 5. If we have angle 90 degree, then we will have 4 minus 1, 3. So, depending upon the angle, we can find the value of this number of images formed in the case of 2 mirrors. If the angle is 0 degree, then the number of image will be infinite. This is a very special case, and in that case 0 degree angle will be when 2 mirrors are parallel to each other. In this case, theta is equal to 0 degree. So, for different angles, we can find the number of images in case of plane mirror. Now, we come to another type of mirrors which are called spherical mirrors. Spherical mirrors are of 2 types. One is called convex mirror, another is concave mirror. Convex mirror is of this type. It is polished from inside, reflection takes from outer side, and concave mirror is polished from outer side, reflection is taking place from inner side. They are part of a spherical surface, and depending upon which portion is polished and from which portion reflection takes place, then we call them as convex or concave mirrors. They are also very important. Now, in case of these mirrors, first of all, this is the concave mirror. There are certain terms which are related with these mirrors. This center of the mirror is called pole. The straight line passing through the pole is called principal axis. The size or diameter of this mirror is called aperture. When a parallel beam of light falls on such a surface, these rays come to a common point which is called F. After reflection from the mirror, this F is called principal focus. The center of this from which this have been taken, that is called C. C is called center of curvature. The distance from P to F is called focal length. The distance from P to C is called R, which is called radius of curvature. And there is sign convention. If the distance are measured as the direction of light, they are taken positive. If they are measured opposite to the direction of light, they are taken negative. In this case, light is coming from left and we are measuring the distance from P and that is towards left. Light is coming from left to right, distance is made from right to left, hence this focal length will be negative. In case of concave mirror, this focal length is taken as negative. If the mirror was convex, then this is the pole, this is the center of curvature. A ray of light, this straight line passing through C is taken as normal. So, this will be following law of reflection. This angle and this angle will be same. So, again this will also be a normal passing through that C. Now, these rays appear to meet at certain point which is called F. Now, in our case, this is the pole, this is the aperture size, P to F is the focal length, P to C is the radius of curvature. Now, light is coming from left to right, distance are also measured from left to right. So, in this case this f is taken positive. This will be very important while solving the numerical problems, whether we have to take f positive or negative, that will depend upon the mirror, which mirror is being given in the problem, whether it is convex or concave. There is an important relation between f and r, which can be derived and proved geometrically. F is equal to r by 2. Focal length is half of radius of curvature, exactly half. If r is equal to 60 centimeter, then focal length will be 60 over 2, that is equal to 30 centimeter. Whenever we are given radius of curvature, we can find focal length. If we are given focal length, we can find the radius of curvature. Suppose focal length is 15 centimeter, then r will be 2 of f, that is equal to 30 centimeter. This relation is very important when radius of curvature and focal length are given. Now, how this image is formed in these mirrors? We take one example. This is the concave mirror, this is the pole, this is focal length, this is C, center of curvature. Object is between f and C, focus and center of curvature. A ray of light parallel to the principal axis goes and strikes the mirror, and after reflection it will come through the focus. Another ray of light that will strike the mirror, and after covering equal angle, then its image will be formed at this point beyond C. We can make such diagrams for various positions of the object. This is the object AB, the image is A dash B dash. This distance P to F is called focal length. This distance is called U, object distance from pole, and image distance from the pole is called V. Then we have a mirror formula. One over U, this U distance from P to A, object distance, plus 1 over V. V की है, V is the distance of the image, and all the distance are measured from the pole P, equal to 1 over F. This formula can also be derived geometrically for both the mirrors, whether it is convex or concave. The formula is same, 1 over U plus 1 over V is equal to 1 over F. And along with this, we have a term which is called linear magnification. It is the ratio of size of image over size of object. We can prove this is equal to I over O equal to minus V over U, or it can be written in term of focal length F over F minus U, or equal to F minus V over F. This linear magnification is ratio of the two sizes, hence it has no units. This is very important in case of numerical